Action.
Okay, we are Ram Engineering, and we created a car lift for Mr. Bob's Auto Shop. Like I said, we created a car lift for Mr. Bob, and the main problem was that he needed an easier way to lift his cars up so he could start fixing them. We had 3 different sketches. Our first one shows a wheel and axle going through a pulley, going to another pulley, and pulling a weight up the inclined plane. The next one shows a screw turning rope through pulleys, and it is pulling down a lever. And the last one is showing a lever pulling up a wheel and axle, which pulls up a blocking tackle.
For decision making, we went through everything, and what came down, we decided to go, well, one of the deals is design 3. We had that because it'd be the most collaborative, but however, it'd be most cost worthy. It would require the most parts, and it'd probably weigh the most. The second one, it could possibly work out. It'd be a lot less to work out, a lot less parts, and weigh a lot less. But the thing is, due to common physics, trying to get it'd be a class 2 lever up to here, it's just unethical. So with the first one, with a simple inclined plane, we decided to go with that. So we brought all the pieces together, and our final sketch, it's not a question mark.
Oh well.
Our final sketch looked a mirror image of this. We decided to go with a simple inclined plane with a wheel and axle and pulley.
So we had 2 wheel and axles. The first one is right here. It had the handle acting as the wheel, and then this sprocket was the axle. It was pulling to the other wheel and axle, which is up here, and this would be the wheel, and this tiny little pole would be the axle. We had a fixed pulley that would just thread the string so it could pull up the weight, and then we had the inclined plane. And we also had a gear system connecting the 2 wheel and axles. And this is a video of it in action. And then for the calculations, the first wheel and axle, which was this small one, the radius of the wheel was 2 inches, the axle was 0.84 inches, the IMA was 2.4. The second wheel and axle, which was that big one up there, the radius of the first wheel was 2 inches, the radius of the axle was 0.06 inches, and the IMA was 33. The gear ratio of the gear system was 30/12, and that worked out to be 2.5. The IMA of the fixed pulley would have just been 1 because there was only 1 supporting string, and the IMA of the inclined plane would be 25/14, which works out to be 1.9. So the total IMA of the car lift would be about 376. The total AMA would have been around 38, because it took about 0.26 newtons to actually pull, and the efficiency was around 10%.
What was that? What was efficiency?
10%.
10%.
Any questions?
In your video, you didn't have that middle sprocket. Did you add that layer for a reason, or why is that there?
I'm not sure. We kind of switched it out. Some people think it looks cool. But
one of the main reasons we put it in is because it restricts the amount of area the chain can bounce around, because if we take this out, it's more likely to move around, but when we put it back in, there's a lot less movement.
Yeah, so you got a sprocket chain there. So when you have a sprocket chain, there's very little slippage for those, but there's a lot of friction, right? So it'd be interesting to get your efficiency with that in there and with it out. Because technically, out, it's okay if that chain's a little bit loose because it's not slipping. It's not like the belt pulley thing, which could slip, right? So it's not slipping. So, maybe you're getting more friction actually by putting it in, even though it does look cool. I will admit.
yeah, I didn't measure it with that in
So
there, so.
it'd be interesting to see if your efficiency changed based on if that thing was in there or not. So, another question over here.
Where does the car get out?
Well, it comes up here, then he drives up to the platform. Wouldn't fit in our 24.
Good call. Anything else?
I have a question. I think on your chart you showed that both wheels had the same radius. Or did I misunderstand that? Real one had a radius of 2 inches?
Yeah, they did. So this handle was the same distance
Okay.
as this.
Okay.
So so you went out to the handle.
Yeah,
That would technically be the radius of that wheel,
yeah, that's what I
right? Okay. So you doubled that, and so that whole distance, twice that is the same distance
said.
that.
Yeah, it's
Okay.
4 inches.
Okay. Anything else? Okay. Nice job.